So, turn this off for a moment. We'll come back to it. So, the way, I just gave you a bunch of stuff. The way to access a bunch of stuff, you have to hit the program button, PRGM, and that's right under stat. The it's the button right under stat. So you hit program, your screen probably looks like this now, because I gave you a bunch of stuff. Okay? Now, all of the stuff that's there, we'll use this, this, and this quite a bit in Math 243 in the remaining couple weeks that we have together. This and this, no, excuse me, this and this are 244, and this are 105, if you ever need to take those classes. If not, we can delete them off your machine.
I think it's 7, right?
I think so. Mine shows 7.
I just had an extra one.
Oh, that's okay. Some of you guys had already had programs on your machines when I dumped them over, so you got more stuff. So please.
Mine still says receiving. Will it just take a while?
Oh no, that's an error. We'll fix that. Let me fix it right now, actually. That way you can play along. I thought it said done when I was over there. Oh, wait a minute. Press second mode. Did it blank?
Yeah.
Now press program. Are they all there? Okay, it works just fine then. Yeah, if anybody else just says receiving, just press second mode to get back to the home screen. I'm sorry, I think I'll bring that up. I forgot that it looks like that for a while until you tell it to get off. So second mode, get back to your home screen, blank screen, then press program. Start with one that's called dist fill. This is the one we're going to spend the most time with today, dist fill. Because this is the one that fills in the distribution. I apologize for the names, they give me 8 letters. Remember 1984, back when file names had to be 8 letters long and you couldn't use punctuation. It's still stuck that way, so I'm like, okay, I have 8 letters, let's make it meaningful. So dist fill was the first thing I thought of, filling in the distribution. I could have called it binomial, except it does more than binomial, more on that later. So anyway, dist fill, hit enter, or select it. So type its number or go down and press enter on it. Then press enter again. What it's going to ask you to do is put in the smallest value of x that's in your distribution.
Like 1?
Not 1, 0, right? Because you could have 0 girls. So the first thing you have to know is what does x stand for? There is a reason I like doing it by hand, because we actually write out what the variables are. I do like that. So, but you guys, I think, confuse that with the can fuse that with this and put it all together. So you know that x is the number of girls. What's the smallest number of girls you could have in your flock? Well, you might have all roosters, right? So you're going to put in 0. And then press enter. What's the largest number of girls you can have in a flock if you buy 4 birds? All of them, 4. So you press 4 and press enter. Now at this point, I'm going to interrupt my program real quick. You guys don't do anything. At this point, what the TI has done is it has created list 1, cleared it out, and put 0 through 4 in list 1. So that first column is now done and ready to go. What it's about to do is have you fill in list 2 through a series of commands. So that's what I'm going to show you next. So you're still there, right? Let me get back with you guys. Okay, 0 to 4. This is why it's called dist fill. I've given you other options. We can talk about more of them later, but the most important one for you guys is binomial. Grab that by pressing 1 or pressing enter. When you press enter, it asks you for the probability. This is the one number you have to do the problem. And what did this whole problem stem from? When the guy at the store told me there's a 90% chance that the chick is a girl. This whole discussion started from the fact that he told me it was 90%. So you're going to put in 0.9. Make sure it's a decimal. You have to put it in as a decimal, otherwise the math gets done wrong. Fair? This is what started the whole thing. 0.9. Press enter. It says done. Pretty boring, I know. Pretty boring. Now go back, press stat, and press edit. And look at what it just did for you. Remember these numbers? Remember? Yes. Look over there. These are all the numbers we calculated manually over there. It does all the math for you through a series of loops that I drew into the program. So it just takes care of all of that for you. All those multipliers. Is it 6? Is it 4? Is it 8? Is it 20? I don't want to make Pascal's triangle down 1,000 rows. I don't have to. It's beautiful. What's the matter, Trey? Press stat A. Stat edit, go back and look. Yes?
It's all one.
Huh, you sure you're in L1 and L2?
Yeah.
We'll take a look. We'll take a look in a second, my friend. Cool. Don't worry about L3. L3 is leftover data from 244. Sorry about that. Clear that out. So now, the beautiful part about having this, and the reason I like this so much is, you now can do everything we've done the entire class on the distribution. You can run the average, can't you? Run the average! One more stat! You know what it is already, it's 3.6. But suppose you didn't know that. You can just run one var stats on L1 and L2, and your average is 3.6. You see? Now you've got a distribution that you can use just like you've always used before. All take zeros, or I just take 4. There it is. You got it. It's okay, don't worry about it, it works.
And then how did you do that one? You just hit it.
Oh, one of our stats. Just like, see, that's the reason I like the program. It bridges the gap between this kind of new idea, and everything we've done all term. It just gives you that one like ladder rung to get, if you will, back to calculating an average. Now you know on average you got 3.6 chickens per 4. 3.6 hens, I guess, per 4 birds. Ask me questions.
That's just awesome.
Oh, good. That's a nice statement. I'll take that statement. It is a time saver. Because here's why. Here's why it's a time saver. Here's why it's a time saver. So a few terms ago, I got a good buddy named Mike Smith. Got a picture of him right here. You might know him from COCC. He works occasionally for us part-time. Used to work full-time. He works for College Excel now. Great dude, great dude. Mike heard me giving this talk with my chicken. This is 3 terms ago, about a year ago. He was in the basement of the library. I was in the basement of the library. One of the few times they let me teach down there, because it's kind of like the wrong person to have a library with me. And I was doing this talk, and he walks in, he's like, "No, this is crap." Roll. I'm like, crap. He's like, "I just heard you say there's a 90% chance of a girl when you buy a chicken." I'm like, well, that's what I've always been told. And he's like, "That's crap. I got a flock, and I bought 7, and I got a boy." I was like, "So you got a flock of 7, and you got 6 girls and 1 boy." He's like, "Yeah, that's right." I'm like, "Well, I would expect that." He's like, "What do you mean you would expect that?" So let's analyze, shall we? Let's analyze Mike's flock. Let's analyze. Use your program. All right? So let's run that program again. Run that program again. Program,
We had 7.
dist fill. He had 7, right? So dist fill, just like before. What's the least number of girls he can have? 0. What's the most number of girls he can have? 7. Okay, fair? Good so far? Working on it? 7. It's binomial again. Every one of those birds that he buys is either a boy or a girl. The binomial probability, I'm assuming it's 0.9. I've never been told anything other than 0.9. Says done. Very. Again, it's not that exciting right now. I apologize. Go back and look at your distribution now. Stat, edit. So, some of this you're going to be like, "Oh, duh, I know that. I knew that." What's the chance he doesn't have any girls? Well, it's 0.000001, which is 1/10 to the 7th power. Just extending what we did earlier today. So that's not going to happen. 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 Wait a minute, there's a 2.3% chance. That's still pretty low. But look, that's 4 girls and 3 boys. There's a 12.4% chance, that's getting high, of 5 girls and 2 boys. There's a 37.2% chance of 6 girls and 1 boy, which means it's below a 50-50 shot of getting all girls. So, using the same argument I did with the guy at High Desert Ranch at home, there's a 48% chance they're all girls. That means there's a 52% chance you got a boy in there somewhere. And I got done, he's like, "God damn it," he stormed off. I'm like, "Dude, I don't mean to be a bastard, but the thing is, when you start putting a bunch of birds in a flock, you're going to have a rooster. Probability says you're going to have a rooster. The more birds you throw in the flock, it gets harder and harder to have all girls. It's going down by a factor of 0.9 each time. Yeah, it gets harder and harder to have all boys, too. But it gets easier and easier to have the boys mixed in with the girls. And this is the problem when you start buying chickens by the dozens at these stores. You want a big flock to make a lot of eggs, you're almost guaranteed to have a boy at some point. I had a student in 244, 45 birds she bought. So let's figure it out. What's the chance they're all girls? What's the chance we got some roosters? Let's do it. This is the beauty of this program. It allows you to analyze that. Ready? Kick out of here.
How many was the largest?
Say that again.
What was the largest number of boxes?
45. 45 was the flock she created. And she kept them all alive, which is even more amazing. I've never looked at mortality of the day-olds. That would be fun to look at too, as mortality. Do you want to play with this? Just to get, okay, you make it sense how it's working. Okay, good. 0 to 45, yes? Yes, it's crazy. It's cool. It's math. Love this crap. Binomial, 0.9. It all stems from 0.9. Isn't that great? All these distributions stem from 0.9. Okay, it's going to think a little bit. It takes a little bit longer to do it now. A little bit longer to do it now. This was just this term in 244. Go look at it.
It's like 0.00.
Yeah. Okay. So take a look at these probabilities. I also gave you another program called dist draw. I want to use that momentarily too. So you're not going to have all roosters. That's like a 1 in a trillion chance you're going to get all roosters. It's not going to happen. None of this is going to happen. All these are very, very small. Very, very small. When do they start getting big? And when I say big, when are they the biggest? Hang on, slow down.
Right there, 31.
Okay, right in there. 36. Interesting. Oh, excuse me. 0.08 right there. No, keep going. There, 19 right there. 41. 19%. That's the largest, right?
Yeah.
Why is that one the largest? So that means he's most likely, or she, Danielle, is most likely, 19.8%, which is not crazy likely, but it's the highest probability, to have 41 girls, which means she also has 4 boys, right? She has 41 girls and 4 boys. 41 girls, that's the most likely outcome. Why is that the most likely outcome? Don't do exact math, do approximate math. For every 10 birds she buys, how many boys is she getting on average? 1! So she buys 10 birds, that means she gets 9 girls and a boy. She buys 10 more, she has 18 girls and 2 boys. She buys 10 more, she gets 27 girls and 3 boys. She buys 10 more, 36 girls and 4 boys. Then she buys 5 more, which means she picks up 4.5 girls, and a half a boy. Which essentially is where this lies, right? A half a boy plus the other 4 is 4-ish. Don't do exact math, do approximate math. So look what happens. What's the chance they're all girls? Less than 1%. What's amazing is she got all girls with that flock. So what does that mean?
Somebody else is in big trouble.
Oh, that's somebody else is in big trouble. That's a cute response. That wasn't the one I came up with. That's good though. Somebody else got a bucket load of roosters. I didn't think that though. What did I think?
She's an outlier.
That's one way to think about it too. She's just a fluky outlier. But again, that's hard for me to swallow only because why would it be that I experienced an outlier? Like what makes me so special that I experienced this rare case? I love that though, Katie. She's definitely an outlier on this distribution.
Maybe her source of chickens was more efficient.
Her source of chickens wasn't 90%, it was higher. That's what I went straight to that. Her sexing probability was not 90%, it was probably higher than 90%. Because if you go higher than 90%, watch this. If we run the program again, dist fill, smallest 0 to 45, just like before. Make it binomial, but make it 99% likely, right? Let it think, it's got to go in. It takes a while, it's still like in that chart right now. Pretty quick, I mean, think about how quickly it does it versus us still doing it. I still be on the first one. And then you go back in and look at it. Look at what happens to the probabilities. We're going to scroll down. Remember how 41 was the most likely before? Look, it's still really unlikely now. Now, the most likely outcome is all girls. Because the probability shifted. You now have a 99% chance of getting girls, which means on average 99 of your birds out of 100. Not 9 out of 10, but 99 out of 100. She didn't buy 100, she bought roughly half of that, didn't she? Yeah, does that make sense? So you got to think of it kind of like a macro scale thing, This is hard to process. So I'm going to go back. You guys still have the original one in with 90% in your calculators? You still have that one in your calculator? So what I'm going to do is I want to go run my program again and get yours back. Smallest x 0, largest x 45. Binomial, 0.9, let it think a little bit, I've written a second program called dist draw. What dist draw does is it gives you a graph of the distribution you just made. So, if you will, press program again, and just select dist draw, which in mine is number 2. And then just press it again, and what it'll do is, it'll give you a graph of the distribution. Now, I like this because it shows you with height how likely something is. The higher it is, the more likely. It's graphing the probabilities on this axis and the x values on this axis. It's taking your t-table and making it graphical. So it's essentially doing a histogram, but I shied away. I made it a line graph because I figured you'd be using it with lots of x 0 to 45 or big. They're big results. So, the problem with it is there's no damn numbers on it. But if you want numbers, just press trace. Just press trace, and then you can scooch and actually get the values that way. You can scooch over to them. So eventually, if you scooch over far enough, your spider will creep up. There it is. Now we're getting into the measurable probabilities. So right up there's your 41. It happens about 20% of the time. And then it starts falling back down once you get too many chickens. So I apologize for Excel, I apologize for the TI because it isn't the best graphics, but at least it gives you something to play with and something to look at, in case you need a more visual, a more 2D versus 1D representation of it. Is that fair? Please ask me questions.
Did you find out where she bought her chicken?
No, I never did. I never did because I keep forgetting to ask her about it in class. She told me at the very end of class one day. I was like, sweet, I'll bring that to 243, and that was 3 weeks ago. And I keep reminding myself to talk to you guys about it, and then I keep forgetting to ask her about it 2.5 hours ago or so. So no, yeah. Long story short. And the thing is, I asked the dude at High Desert Ranch at home, like, where do you get your number from? He's like, I don't know, it's ballpark, 90, 95, 99, 85, I'm not sure what it is. I'm like, well, that makes a big difference, you know. I mean, being off by 10% makes a huge difference in the analysis. I mean, that's Danielle's probability distribution, right? Suppose, watch this, I'm going to rerun the program again with 99% again. So I'm going to rerun this again, 0 to 45, binomial with 99% probability. And then I'm going to redraw the graph again. Remember what hers looked like? A little bell curve on the right side? Here's what it would look like with 99% probability. In other words, and it never comes back down again. It never comes back down, which means the most likely outcome is all the way at the end. That makes a huge difference. I mean, that means buy more girls. Or, excuse me, buy more birds, you're most likely to get them all to be girls. To a point. There's a limit on that too, we'll talk about. Fair? Eric, ask me that question.
Why doesn't it go back down? I mean,
Mathematically.
There's still a 0.01% chance.
Absolutely, absolutely. You got it. The chicken, she only bought 45 birds. If she buys 1,000 birds, for every 100, there's going to be 1 boy and 99 girls. So out of 1,000 birds, you're going to have 10 boys, most likely. You're absolutely right. But only for 45, or 45 birds, it can't go back down mathematically. It's going to ramp up and stay up. Good, very good question. Very good question. Make sense? Ish? So the binomial is a wonderful tool, not just for chickens. I mean, the chickens is one thing. It comes in super handy for other research. So what I want to do right now is,